Okay, so we are going to look and see what happens when we have intersections in our circle. We're going to have three different types of intersections. We're going to have interior, exterior, and then we're going to have intersections that happen on the circle. And they all three have different rules. So these are rules that would be very beneficial to memorize. Okay. So the first rule that we're going to look at is when we have an intersection in the circle that happens inside of the circle. Okay, so in this picture we have two lines, okay, which are our secant lines. They happen to intersect right here at this point inside the circle. So this is an interior intersection. Okay, so in order to find out what angle 1 is, you actually have to look at the arcs that are directly across from angle 1 on both the left and the right hand side. So for angle 1, we have this arc here, AD. We also have this arc here, BC. So what you're actually going to do is you're going to start with the angle, and you are going to take half of the arcs on either side added together. So you're actually taking the average of the arcs on either side. So you're going to take half of arc AD plus arc BC. Okay. So similarly, to find angle 2, you're going to look at the arcs on the top and the bottom. You're going to take half of them added together. So half of the top arc AB plus the bottom arc DC. Okay. So you're really essentially taking the average of the arcs that are directly across from the angle. Okay. The way that I like to write this for the interior intersection is the angle equals half, and then I take the arc plus the arc. Okay, you just have to know where the arcs are. Okay, so let's look at some examples of this. If you look at number 1, it asks for the angle AED. So this right here is the angle. I'm going to call it X, okay? This is what I'm searching for. So I'm going to start with the angle. I always start with my angle in this equation. I'm going to set that as X, because that's the angle that I'm looking for. I'm going to set it equal to 1/2, and then I'm going to add the arcs that are directly across from it, which is 45 plus 109. So that's something that you can just plug into your calculator. So 1/2 of 45 plus 109 is 77 degrees. That's my angle that I was looking for. Okay. I'm going to skip around some. So I'm going to look at number 3 next. It asked me for the angle YWX. So this is the angle I'm looking for. I'm going to call it X. I'm going to have X equals 1/2. I've got to add the arcs around it. But do I know these arcs that are around it? I do not. What I do know is that I have these arcs that I don't actually even need. So what I'm going to do is I know that if I take these two arcs away from 360, that will leave me with these two together, which I already need to add together, so it will give me the number that I need. So 360 minus 43 minus 81. So that is going to be 236 degrees. That's what both of these are together, and I already have to add them, so that's the number that's going to go in the parentheses. So 1/2 of 236, my angle is 118 degrees. Okay. Let's look at number 4. It asked me for the arc this time, LK. So no matter what, I have to start with my angle. My angle is 62. So I start with my angle, I set it equal to 1/2. I'm going to name this arc X. And I have to add my arcs together. So X plus 74. Okay, instead of distributing the 1/2, I'm going to do what I've done in the previous lessons, where I'm going to multiply 2 to both sides. So 2 times 62 is 124. And I'm left with what is inside of the parentheses. So I've got to take the 74 away. So x is going to leave me with 50 degrees. Okay. Okay, I'm going to look at number 6 next. So in number 6, I have to find the arc QT. Okay, so I'm going to name this piece X. But I do not have the angle that's directly across from it. Okay, but I do have one angle here, is 79 degrees. And I know this 79 degrees and the angle that I need form a straight line, which has 180 degrees in it. So 180 minus 79 is going to be 101. That is the angle that I need to start my equation with. So my angle equals 1/2 of my arcs added together. I'm going to let you work that one the rest of the way out later on. Make sure you come back to it. So those are intersections that happen inside of the circle. Now we're going to look at intersections that happen on the circle. They actually create those intercepted arcs, okay? Or the intercepted angles, I'm sorry. Okay, so what we're going to do is we're going to look at this equation, or this picture here, and we're going to create an equation off of it. So our intersection here happens at A, and it happens to be exactly on the circle. So in order to find angle 1, we have to look at the arc that is made up of its endpoints, A and B. So this angle is going to be exactly half of the arc that it's across from, half of arc AB. Okay? So the same for number 2, it's going to be half of the arc that it's across from. It just happens to be across from a major arc. So this arc would be called ACB. 3 letters to describe it because it's a major arc. Okay. So on this, what I like to write is the angle equals half of just the one arc that it's across from. So number 7, it asks for angle DEG. That's the angle. I'm going to call it X. So I'm going to put X equals half of the arc that it's across from. So half of 308. So 308 divided by 2 is going to be 154 degrees. Okay. So number 8. We're looking for the angle DBC. So this is my X, that's my angle. I'm going to start with my angle. My angle equals half of my arc. But I do not know this arc. I do know the rest of this circle is 192 degrees. So I could find this arc by taking 360 minus 192. I'd be left with 84 degrees. I'm sorry, not 84, but 168. Okay, so I have to take half of 168, and I would get 84. Okay, so I'm looking for this arc XY. It's kind of hard to see in the picture, but I'm going to name it X. Now, I don't know the angle, and I need to start with the angle. I do know this angle, though, and it's a part of a straight line. So in order to find the angle that I need, I would take 180 and I would take away 151. So that would leave me with 29 degrees. That's the angle I need to find half I need to find the arc. So I would take and I would multiply by 2. So 2 times 29 is 58. So the arc is 58 degrees. Okay, so make sure you have that written. Alright, we're going to go on to the back page. We're going to look at the exterior intersections. One last type of intersection. It happens on the outside of the circle. So here's the intersection in this picture where two secants intersect. To find this angle, you're going to take 1/2 of the larger arc that it's across from. Here's the larger arc, which is CE. And you're going to subtract the smaller arc that it's across from, which is BD. And you're going to solve all of these the same way. So for this type, where you have a secant and a tangent intersecting, you're going to take 1/2 of the larger arc, which in this case is BD. And you're going to subtract the smaller arc, which is BC. Okay? And then the last one, where you have two tangents intersecting, in order to find this angle A, you have to take 1/2 of the larger arc, which in this case is a major arc, which is BDC, and subtract the smaller arc, which is BC. So just as a general rule on this, I like to write the angle equals 1/2 of the larger arc minus the smaller arc. Okay, that's the rule for the exterior intersections. So we're going to look at a couple examples of these. These aren't too bad. Okay, so let's look at number 10. We want to find the angle KLM. So I'm going to name that angle X. So in my equation, I'm going to start with the angle X equals 1/2 of the larger arc that it's across from, 140, minus the smaller arc. We've always got to do the larger minus the smaller so you don't end up with a negative. So you can plug this in exactly as it is written in your calculator, 1/2 parenthesis 140 minus 66. And you end up with 37. That's it. So let's look at number 11. We want to find the angle ABC. So this is going to be our X. We're going to start with our angle, which is X, equals 1/2 times the larger arc that it's across from. Do I know that larger arc? I do not. So what I'm going to do is I'm going to try to find it. I'm going to take away these two arcs from 360 to find it. So 360 minus 62 and 88. And I get 210. So that's the larger arc minus the smaller arc. So if I plug that in, I get 74 degrees. Okay. Let's look at number 12. We want to find the angle again, PQR. I'm going to name it X. I'm going to start with the angle X equals 1/2 of the larger arc, which is 313, minus the smaller arc, but I don't know the smaller arc. But it's what's left of the circle, so 360 minus 313 will give me the smaller arc. It'll give me 47. So I just have to type that into my calculator. 1/2 of 313 minus 47. And I get 133 degrees. Okay, I'm going to let you figure out 13. Let's go on to 14. So to ask for the arc from S to W, this is the arc this time, but we still have to start our equation with the angle. And the angle in this case is 40 degrees, so that's what we're going to start with. So 40, the angle, equals 1/2 of the larger arc, which is x, minus the smaller arc, which is 75. So just like in the previous problems, you want to get rid of the 1/2 by multiplying by 2. So you have 80 equals x minus 75. So you would just add the 75 to get 155. That's your answer. So let's skip down to number 16. I want to find this arc right here, MK, so I'm going to name it X. I got to start with my angle, which is 56. Set it equal to 1/2 of the larger arc minus the smaller arc. So now we've got to multiply by 2 to get rid of the 1/2. So 56 times 2 is going to be 112. And I'm left with 160 minus x. So in order to solve this one, you've got to move the 160 over. So in order to do that, you have to subtract 112 minus 160 in that order. And you get negative 48 equals negative x. But since they're both negatives, the negatives cancel, and x ends up being just a positive 48 degrees. Okay, so I'm going to let you solve the rest on that page. We're going to move on to the next page now. So it says arcs, angles, and algebra. So up at the top of this page, I want you to write down the rules that we had generalized on the other paper, which is where you have an interior intersection. So the rule is the angle equals 1/2 of the arc plus the arc. When you have on the circle intersection, you're going to have the angle equals just 1/2 of the arc. And then one more rule is the exterior, where the angle equals 1/2 of the larger arc minus the smaller arc. Okay, so make sure you have that written down. I'm going to give you a few minutes to write that. Okay, so you should have that written now. And now we're going to look at the types of intersections that we have here. So we're going to solve for x. This is just throwing a little bit of algebra into what we were doing before. So on number 1, this is an interior intersection. The intersection happens on the inside. So you're going to use that first rule here. You're going to start with the angle, which is 3x plus 23. You're going to set that equal to 1/2 of those arcs added together. Okay, so you could multiply by 2 to the other side. In this case, this is simple to just plug into your calculator, so that's what I would do. I'd leave this 3x plus 23, and I would just, in my calculator, put 1/2 times 55 plus 75 to get 65. You're going to move the 23 over by subtracting, and then you're going to divide. Okay. And I'm just going to work a few of these problems with you. So, like on number 3, this intersection happens on the circle. So you're going to follow the rule, the angle equals half the arc. So my angle in this case is the 6x minus 38. That is going to equal half of my arc. So again, I'm just going to take half of 140, which is going to be 70. Okay. And then I'm going to move the 38 over and get 108 and divide. Okay, on number 5, this is exterior intersection. So you're going to start with the angle, which is 7x minus 1. Set that equal to 1/2 of the larger arc minus the smaller arc. So I just plug all of that in. Those are all numbers that can be easily plugged in. 1/2 of 161 minus 65 is going to give you 48. If you add the 1 over, you'll get 49. And if you divide, you get 7. Okay. So let's look at number 7. So on number 7, it's telling me my arc CB is 5x plus 41, so I'm just going to write that in. It's telling me my arc AD is 7x minus 19. And then my angle AED, this angle right in here, is 89 degrees. So this is an interior intersection. I'm going to follow that rule. I'm going to start with my angle, 89. I'm going to set it equal to 1/2 of the arcs added together. So I'm going to add together 7x minus 19 and 5x plus 41. Now, instead of distributing the 1/2 in here, I can't easily put that in my calculator, so I'm going to get rid of it by multiplying. This is where it's easier to multiply. So 2 times 89 is going to give me 178. And then what I'm going to do all in one step over here is combine my like terms within this parenthesis. So the 7x and the 5x will add together to give me 12x. The negative 19 and the 41 will combine together to give me 22. So now I have an equation that I can solve. I'm going to move the 22 over by subtracting 178 minus 22. I get 156. And then my last step is to divide. So I get 13 for x. But what it wants is AD. So I'm going to plug it in to AD's equation right here. So 7 times 13 minus 19 is going to give me 72 degrees. Okay. Okay, we're going to look at a couple more on the back, and then I'm going to let you work on the rest of these. So let's go ahead and look at number 10. I'm going to skip around a little bit. And by the way, on number 9, they messed up, and they should have not put that arc over that angle. It is an angle. Oh, actually, no, it is an arc. Okay, so this is an arc, not an angle. Angle, this is arc BED. Okay, so this should be 15x minus 47. Arc BD should be 9x minus 1, and it's asking for the angle CBD. So this is the angle. Okay. Actually, let's go ahead and work this one. So it's asking for this angle, but first of all, let's just look at what we're given. We're given both of these arcs, which make up the entire circle. So I'm going to go ahead and just add them together to give me 360 degrees because they make up the entire circle. So if I combine my like terms, I'm going to end up with 24x minus 48 equals 360. I'm going to add the 48 over, so I have 24x equals 408. I'm going to divide, so I get 17. Now in order to find this angle, I'm going to plug it into the arc that it's directly across from. So 9 times 17 minus 1. That is going to give me 152 degrees. But I know that my angle is half of that. My angle is half of my arc. So half of my arc would be half of 152. It would be 76 degrees. Okay. Okay, let's look at number 11. Last one that I'm going to work with you, and then you're going to work on your own. So number 11, it tells me that my arc NJ is 170 degrees. And then my arc MK is 5x plus 8. And my angle here is 4x plus 3. So this is exterior intersection. I have to start with my angle, 4x plus 3. I have to set that equal to 1/2 of my larger arc, 170, minus my smaller arc, which is an equation, so I've got to put it in its own set of parentheses. Okay, this is a more difficult problem, but just follow along, you'll do fine. I want to get rid of my 1/2 first by multiplying by 2. I have to multiply this side by 2. That means I have to distribute since it is an equation. So if I distribute, I get 8x plus 6. Now here, just like in our algebra problems that we just worked the other day, you have to distribute the negative within the parentheses here. So I'm going to have 170 minus 5x minus 8. So let's combine our like terms over here. I'm going to have 8x plus 6 equals negative 5x plus 162. I'm going to move my 5x over by adding it. I'm going to get 13x plus 6 equals 162. I'm going to subtract the 6, so 13x equals 156. And I'm going to divide, so I get 12. Now it wants my angle MLK, so plug it into MLK, the equation for it. 4 times 12 plus 3. It's going to give me 51 degrees. Okay, so it's your job to finish up the rest of those problems that we skipped over. So go ahead and get to work. Make sure you are quiet and working.